Alright, so I got this completely stock Razer SX500, and I didn't get a video of it running stock, but it's really slow. So I think the first mod we're going to do is we're going to take the 36 volt lead acid batteries, and we're going to put some, first I'm probably going to put some lithium polymer batteries, and we're going to try to put 48 volts on the stock controller, and we're going to ride it like that and kind of see how it is. The whole goal of this bike is eventually go brushless and the whole 9 yards, maybe 72 volts, that'd be cool. But for right now, we're just gonna get rid of the stock boat anchor batteries, put some lithium batteries in it and go ride it and kind of see how it is. But out of the box, it really only does about 15 miles an hour. It's pretty gutless. So it's got good torque, but it tapers off really fast at the top. So I'm gonna get these ripped out. Once I get these ripped out, I'll show you guys how I'm gonna mount them. And also the goal is to be able to put the plastics back on and make it look completely stock. I'm not putting a BMS on it for now. We're just gonna use a RC charger to keep the batteries charged. But once I get it all back together, we're gonna go ride it. And then I also have another bike, an SX500 that's already brushless, 48 volt, and that's got a lithium iron phosphate battery on it. So it'd be cool to drag race this versus that. Obviously that one will be faster, but we're just gonna do incremental steps on this one before we go full brushless. So I'll show you guys once I get it all done. All right, so currently I'm pulling almost 500 watts on our little power station deal. I got the solar panels plugged in right now. The sun's not out, so we're not making a whole lot of power. But right now we're charging this big old LiPo at 8 amps, and then we're charging the electric dirt bike. So this is 48 volts at 5 amps, so pretty good amount of power. I'm just keeping an eye on the cells because I don't have a BMS on this. So we're just gonna let those get to like 3.55, 3.6. But this thing works freaking really good, and I got the wooden battery right there hooked up, so everything seems good. But this is the main reason I built this thing, is because this charger here is a DC only charger, and I can push as much power as I want through that, and this setup is very well capable of doing so. But just I wanted to show you guys. So I'm gonna top this dirt bike out, and then I'm gonna get the other one put together, and maybe we can go for a little test rip and kind of compare the two. So this one's the one that's brushless. As you can see, it's got the 1800 watt Vol motor on it. It's not cleaned up yet. I'm eventually going to put the box on it, put a BMS on it, tidy up all the wiring. There's the mode switch. It's got 3 speeds. I want to put that near the handlebars so you can control it. But that's it for now. Alright guys, welcome to another video. This is all about batteries. So I went on battery hookup and ordered a bunch of these K2 Energy 3800 milliamp. I believe they do 15 amps per cell, so that's pretty good. I got a bunch here. I got 192 in this box. We're gonna open those up, and then I have a pack I've already built. This is a 10S4P, so this is 13.2 volts at 38 amp hours, or if you do the watt hour conversion, it's fairly large. And then I started experimenting with 3D printing some holders, because that's just like hot glued and duct taped together. And then here's a balanced plug. There's no BMS on this. It's just like a normal, like, I guess you could say like a hobby battery. You have to use a smart charger to charge it. But these, I'm gonna experiment using, I'm gonna build like these cell modules, spot weld them all together. That one's also spot welded. I'm gonna spot weld these into 1S modules, 10P, and then I'm gonna build pretty much the same thing as this, but we're gonna use these cell holders, so we're gonna give those a shot. These are the same cells that are on the Razer MX650 build. So I'm gonna do a full video once this thing's kind of done getting tested out. Right now I'm just charging it after a 6.5 mile ride. I just want to see how much milliamp hours it used. So it's already put in 1500. We're at 3.4 volts per cell. Once it gets to 3.65, it's full. So we'll see what that takes. But these are also the same cells. As you can see, you can barely see the white. These are also kind of ghetto made, but they do work. No BMS as well, just a hobby charger to charge them, which is a pain in the butt, but I did order 2 of the Dali 16S BMSs for lithium iron phosphate, and they're Bluetooth, so it'll be really nice to be able to, you know, hook it to your phone, look at your discharge, look at your voltages, look at all the cell balancing and all that good stuff. So, and then I want to be able to build a really big battery. So my plan is I'm going to build 4 of these out of these, so it's going to be a 16S 38 amp hour battery. So it'll be like the monstrous 48 volt, and I want to be able to make a super long range scooter or dirt bike, whatever. So we're gonna build this one up still. This one still has a brush motor on it, but we might just run it with this with a brush motor just to see how it is. It is gonna be a lot heavier with this many cells on it, but the whole goal of this project is to have something that goes about 30 miles an hour, which is what that one does. but be able to go like, 20, 30, 40 miles maybe. And it'd be really cool to do a full range test and actually see what we get. So I'm going to get all the cells out and I'm going to kind of lay them out just to see visually how much room they're going to take up and all that good stuff. So I'll show you guys when I get them all unboxed. The bane of existence, packing pay nuts. These are going to make a huge mess. Unfortunately, when I bought this case of batteries from Battery Hookup, these are a little cheaper to buy. It's 120 for, I don't know, it was like 260 shipped, 280 shipped. But of course I put 2 of these in my cart to buy 2 more. I go to buy them the next week when I got the money and they're out of stock. So I had to buy these in boxes of 16. So it's a little more expensive. You get a little less cells, but I really do like these lithium iron phosphate cells, and they, when they're gone, they're gone. So let me get these open. All right, here's our box of 16 cells. It's a lot cheaper to buy them in a big bulk case like this, but Battery Hookup ran out. So I ended up just buying a bunch of these just so I could get some more cells. It's more expensive to buy them individually like this, but what are you gonna do? So I'm gonna get them all open and we'll see them on the table. All right, got all the cells unboxed. So from here forward, it's 300 cells or 260 cells total. And that comes out to about 3,100 watt hours or 3.1 kilowatt hours. So that's pretty good. If I end up building 4 of those to put on an electric bike, a dirt bike, whatever, that's gonna be 2 kilowatt hours. So that's probably more than enough for a dirt bike. So anyways, now I'm going to kind of figure out how I want to configure these. Also, I got some cool cooling fans from Battery Hookup as well, and I put some more cells in there, but that's it. So pretty excited to show you guys the batteries, and obviously as I start building packs, I'll definitely keep you guys updated. If you have any questions, leave me a comment. Alright guys, we got all our cells configured. So this is going to be a 6P16S. So we're going to parallel all our parallel groups first with the spot welder, which is charging up right now using nickel strip. And then once we get all those done, flip it over to the other side, then we're going to series them up. Once that's done, we'll solder the balance wires on, we'll solder the main leads on, attach the BMS, mount this to a piece of wood, and put it on the Razor dirt bike. So I'm going to go ahead and get this thing all spot welded up. It's going to take quite a while, and I'll show you guys when I'm done with that. Alright y'all, got my parallel connections done. So now I'm going to work on the series connection. So we're going to go, I'm going to make this the main positive. So we're going to go positive, negative, positive, negative, positive, all the way down this way and all the way down this way. And then whenever I cut the strips, I'm left a little tab right here. So when I go to put the balance wires on, it'll be easy to attach the balance wires. I got to put, I believe 17 wires. They got to be soldered on. And then I'm going to slap the BMS on. I'm going to cut a piece of wood the same size as this to mount this to. And then we're going to put our discharge leads. We're going to use an XT90 connector, and that's it. Then we're going to wrap the battery up, slap it on the bike, and we're going to go from there. But I'll show you guys once I get all the series connections done. We'll measure the voltage, make sure the voltage is what it's supposed to be. What I should do is stick a meter on these now, which I probably will, and just make sure these are all the same. Make sure one of the cell banks isn't low or for whatever reason. These are all brand new cells, so we shouldn't have any issues with that. But I'm going to go ahead and make those series connections, and I'll show you all what that looks like. And if anyone's curious, this is the spot welder I'm using. I got it on Amazon. I had a transformer based machine before this one, which worked all right, but it didn't have the leads. And this thing's nice because it has an auto or a manual mode. And what I do is I just press down and use a little pedal, and it does a little spot weld. And I've used the heck out of this machine. I really like it. So far so good. I think it was like 250 bucks on Amazon. So if you're gonna spot weld your own packs, that's not saying this is the best, but this is the one I use and it seemed to work pretty good. So I'm gonna get to it. I got some more nickel strip to cut up, and I said I'll make little seriesing strips, and I'll probably put like 3 or 4 per string. That way they can carry a lot of current, because I want these, each cell can do 15 amps, so it'd be 15, 45, or 15, 30, 45, so 90 amps total. If I'm really pushing these batteries to the max, I can do 90 amps out of this entire pack. So 90 amps times 48 would be your maximum wattage, which would be pretty high. So it would be nice to actually build the pack to be able to push maximum current if I wanted to do so. I won't in this situation. I think I'm only running a 2,000 watt motor, which is only like, I think it's like a 35 amp controller. But 90 amps max, we could always pump the power up a little bit, maybe put a better controller or whatever. But anyways, I'm gonna get to it and I'll show you guys when I'm done. Alright guys, so I got the series connections done, which are a little bit scary because if you short these out wrong, you short the whole battery out. So, and then here's the connection between the 2 packs. So that's it. It's positive, negative, boop, 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 boop. All 16 are in series. So we can take our meter Peter, put the red one there and the black one there. Oh my God, look at all that power coursing through this thing. So that's it. Now I'm going to add more bus bars because I've only had one just to get them all configured right. That way I don't gotta keep flipping the battery over. So I'm gonna put a couple more on each. Then we'll put a balance harness on it. Then we'll put main power harness on it. Then we'll tape it up with duct tape and make it not look super ghetto, hopefully. And that's it. So we keep working at it. All right, got the battery all done. She's all spot welded up, series parallel. So it's a 6P16S battery. These are discharge connectors. This is the BMS balance. We're gonna use this Dali Bluetooth BMS with the Bluetooth module. So I'm gonna get all this connected to that, and then I'm gonna tape this to this piece of wood, and this is gonna mount to the Razor dirt bike at an angle. And the wood's gonna take all the weight, and we're just gonna throw some zip ties on it for the time being until we get everything wired up. But that's it. This battery came out pretty good. I'm really happy with it. It's pretty heavy and pretty big, but hopefully we should get at least 20-25 miles of range out of this thing. And it's 6P, so 6 times 15 is the amperage we can push out of this thing. I think it's pretty well built. Then we have XT90 anti-spark connectors for the discharge connectors. So that's it. I'm going to get this all put on that, on the piece of wood, and we'll get it mounted to the bike. And then once that's all done, we'll wire it up and test it.